Hi, this is Professor Sarwanan from Department of Mechanical Engineering. Today we are going to see the second year Mechanical Engineering Applied Thermodynamics subject, one of the practicals, which the title of the practical is this one: Morse Test on Multi-Cylinder Petrol Engine for Determination of the Friction Power. Basically, Morse is the scientist who has done this experiment for determining the frictional power. Thus, this friction power, this Morse test can be done both the petrol engine as well as the diesel engine. Only the precondition is it must have the multiple cylinders. That is the precondition. Now, in the petrol engine, the Morse test is done by cutting off the spark plug connection. That means cutting off the firing into the combustion chamber. In the diesel engine, it is done with the help of disconnecting the fuel supply. Now, we are having the petrol engine. In the petrol engine, what we are doing is, we first run all the cylinders. First run all the cylinder at a particular speed and keep the speed constant. Now, we measure the load. We measure the torque for that. With the help of the torque, we will be getting the brake power, that is the 2 pi mt upon 60. You will get the brake power when all cylinder is working. Now, we will see the setup. In the setup, we will see more details about this. This is the 3-cylinder petrol engine which we are going to use for the Morse test. So, here are this is the engine, this is the distributor for the engine. This is the air intake, and now here in between we have here the eddy current dynamometer, which is used for loading the engine. How much load is acting on the engine will be displayed in this digital meter. Now this is the control panel for the 3-cylinder 4-stroke petrol engine for the Morse test. In this, the working condition of this engine is like all the cylinders must be running, and at that time we need to take the speed of the engine. What is the speed? And the loading, as we have seen the loading unit from the dynamometer, we will measure. This we are noting down. First reading when all cylinders are working. The second step is, what we have to do is, we have to maintain the speed, at the same time cut off the cylinder 1. That is, cutting off cylinder 1 is this. That means disconnecting the fire supply. Now, cylinder 1 is cut off. At this time, the speed will automatically reduce. But we need to maintain the speed constant. For that, we are reducing the load so that it will attain the previous speed when all cylinders are working. So now this is the second reading which we are noting down. And the third one, we need to do second cylinder cut off. That means, again we know that the spark supply to this cylinder 2 is cut off. Then note down that means at this time, to adjust the speed to the previous older speed, we adjust the load if required, and then take the readings, observation readings. Similarly, we do it for the cylinder 3. Cylinder 3, we do this, repeat the same process. As we have seen how to take the readings in the setup, now we note those readings in this observation table. Say, what is when all cylinder is working, what is the load, what is the speed. For that we calculate the brake power, that is the BP, 2 pi mt upon 60. This BP we are calculating. Second, when first cylinder is cut off, what is the load and what is the speed. Speed we know, the same speed we maintain, but load will reduce. And for that, using this formula, we calculate BP1. And similarly, we calculate BP2 and BP3 for the respective cylinder 2 and cylinder 3. So by this, we will be having 4 different brake powers. That is the BP1, BP1, BP2 and BP3. With the help of this formula, indicated power is equal to 3 BP minus summation of BP1 plus BP2 plus BP3. We will be getting the IP. Now we know the formula FP is equal to BP. IP minus BP. So with this, we will be getting the frictional power with the help of the Morse test. So today we have seen the practical session. How to determine the friction power using the multi-cylinder petrol engine with the principle of Morse test we have seen now. Thank you.